Hi children, in today's class, let's take up one important theorem based on triangles, which is the Thales theorem or the basic proportionality theorem. Before moving on to the actual theorem, let's recall the concept of area of a triangle. We all know that the formula to find area of the triangle is half into base into height. Here, height always refers to perpendicular height drawn to the base from the third vertex. Secondly, we can observe that the perpendicular height may be inside the triangle, on the triangle, or outside the triangle depending on the type of the triangle. This is the statement of the theorem. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Now, let's break up this statement. If a line is drawn parallel to one side of a triangle, so what do we have? A triangle ABC. And a line parallel to BC. Then what do we have? To intersect the other two sides in distinct points. Here we draw the parallel line long enough so that it touches the other two sides at D and E. Then what do we have? The other two sides are divided in the same ratio. What is the meaning of the word ratio? Ratio is comparing quantities of same unit. Here we are going to compare AD and DB with AE and EC and prove that the ratios are equal. Now let's move on to the actual proof. Here we are going to make use of area of triangles concept to prove this theorem. First, let's take up AD and DB. We create two triangles with AD and DB as base and make their areas as one ratio. For base AD, there is already a triangle ADE. Thing we want is the perpendicular height. For the first triangle, we draw the perpendicular height EN. For BD, we create a triangle by joining BE. Since DBE is an obtuse angle triangle, we have already seen that the perpendicular height will fall outside the triangle on the extension of BD towards A, which once again happens to be EN, because we cannot draw two different perpendicular height from the same vertex. So, EN is the common perpendicular height for both the triangles. If you understand this, the theorem is almost over. So, area of triangle ADE is half of AD into EN. Again, area of triangle BDE equal to half of BD into EN. Writing them as a ratio, half and EN gets cancelled and we get AD by BD. Now we are going to apply the same logic to the other side. Draw perpendicular height DM. Join CD to create a triangle. Find areas. Write them as ratio. Now we cannot jump into the conclusion that the two ratios are equal, because if the right sides should be equal, then the left sides should also be equal. Now look at the left sides. On top we have area of triangle ADE on both the circumstances. But look at the denominator. Area of triangle BDE and area of triangle DEC. Only if these two areas are equal, then AD by DB will be equal to AE by EC. Only when the two triangles have the same base and the same height, then the areas will be equal. In these two triangles, BE is common, which is the base of the two triangles. Since the two triangles lie between the parallel lines, the height will also be equal. Since both the height and the base are equal, these two triangles are equal in area. Since the left hand sides are equal, then automatically right hand sides will also be equal. Hence AD by DB will be equal to AE by EC. Now let's move on to the visual proof. In the last step, we proved the areas of triangles BDE and CDE are equal. Now look at the answers. The areas are equal. Even if I adjust the lengths, the areas remain the same. Next, let's compare the ratio of the areas of triangles ADE and BDE with the ratio of the areas of triangles ADE and CDE. What do you observe? The ratio remains the same. Even if I change the length of the sides of the triangle. Now let me rearrange these areas to make you smile. Now what do you observe? The first two areas are equal and the second two areas are also equal. Also we observe that the numerators are equal and the denominators are equal. So naturally the answers will also be equal. So simple, isn't it? Keep smiling. Catch you in another video. Thank you, children.